All right, so we're going to calculate mean, standard deviation, and sample size first. Here are the operators that we're going to use. Now to calculate this, you'll always need to start with an equal sign. So I'm going to say equal average and then select the data set and enter. All right. Standard deviation equals stdev.s. Select the data set, close the parentheses, and enter. And then sample size is equal count. Select the data set, enter, and 44. All right, then to get the same 3 here, all you do is select this. You'll see a little dot show up right here, and you drag this over. All right, now we have the mean, the standard deviation, and the sample size. All right, now what does this stuff mean? Well, standard deviation is a measure of spread. So I have the calculations here and a description of standard deviation. I'm going to go through this. Standard deviation shows how much variation there is from the average, from the mean. If data points are close together, that means the standard deviation will be small. If data points are spread out, the standard deviation will be larger. Typical data will show a normal distribution. This is a normal distribution. So this would be like a histogram. So this would be on the x-axis number of drops, where this is the average number of drops right here, like 40. And then the standard deviation shows how wide that normal distribution is. So this normal distribution is this wide. If it's a low standard deviation, it will be this wide. If it's a big standard deviation, it will be much wider. It'll be more spread out. So how does this work? A typical data will show a normal distribution. In a normal distribution, about 68% of all values will fall between 1 and -1 standard deviations from the mean. So our mean, if we go back to our data, our mean was 41, standard deviation was 11. So that means 68% of all of these values fall between 29 and 51. 29 is 40 minus 11, 51 is 40 plus 11. Does that make sense? So I'll show you on here. So this would be 41. This would be 52 and 30. 52 and 30. And 68% of all the values would fall in here somewhere. Does that make sense? Kind of? 95% would fall within 2 standard deviations. So that would be 41, 52, 63, and 41, 30, 19. So 95% of all data points will fall within 2 standard deviations. And then 99% of all data points fall within 3. Everybody got that? So the take-home lesson here, standard deviation is a measure of how spread out the data are. And you can see from our standard deviation, I'm going to collapse the data here for a sec. So the mean, this is regular water versus soapy water. The standard deviation for the regular water, 11, that means the data were pretty spread out. For the soapy water, our data were much more clustered together. All right, now, next, we're going to make a histogram. So first watch me, and then you can do your own. Actually, we need to make 2 histograms. So watch how I do this. We're going to make a graph. So I'm just going to select the data. Start and with including the title. So regular water down to 64. So just the data. Click on the insert chart. And then chart type, select histogram. And make that smaller. And then do the same thing for soapy water. So 2 histograms, select it, select chart, and histogram, and make that smaller. I'm going to change my zoom so I can see my stuff here. All right, now you can do that. So do that right now. Make the 2 histograms. Select the data, including the title. Click chart. So a problem that we have here, we want to be able to compare these 2 histograms, but the x-axes aren't the same. This one goes from 10 to 65. This one goes from 10 to 40. So we want to change it. So let's start with this one. And we're going to customize it. And I want to change the horizontal axis. And I'll have it go from 10 to 70. And on this one, I also want to go from 10 to 70. All right, so do that right now. So now the x-axis is the same. They're stacked on top of each other. And now we have a good visualization of how these 2 are different. Did everybody do this? So one more adjustment to the histograms. I think the bins are a little bit too big. So I double click to get these options up again. I'm going to go back to customize and histogram. And the bucket size tells you how big these bins are going to be. So I'm going to change it to 5 instead of 10. And do that for both of them. All right. So now this says I have, for the regular water, there's 1 value between 10 and 15, 2 between 20 and 25, 8 between 35 and 40, 3 between 50 and 55, etc. And you can see this is somewhat of a normal distribution. This one is somewhat of a normal distribution. And keep it like this so they're the same. I want you to copy paste this into the document. So copy. And where it says create, for number 2, that's create 2 histograms. That's not right. Make it a more reasonable size. Now what's kind of cool about Google Sheets, I selected to post unlinked, but you could post it linked, and then if you added more data, it would automatically update these, but I'm not interested in that. And one more thing we can do before we move on. It asks for mean, sample size, and standard deviations for both groups here. So you can grab those. And again, I believe you're going to be able to just copy paste. If you minimize this, copy, paste. All right, so last few people are finishing up here. Let's go on to the next question. Describe how the distributions of the two groups are different. How are the histograms of distributions from large versus small standard deviations different? All right, so you can see that not only was the mean higher for regular water, so more drops of water, but the standard deviation was bigger. It was more spread out. That is, the average was 41, but all the pennies weren't very near 41. There were some that were much higher, some that were much lower. Whereas the mean was much lower for soapy water. It was like 19 or whatever it was, 17 and a half. And they were all right around 17 and a half. The mean was, the standard deviation was much lower, and so the data were less spread out. And that's what a histogram shows. It shows how spread out the data are. A histogram lets you visualize standard deviation. Okay, moving on. The next idea. So standard deviation is how spread out the data are. The next value that we're going to see is standard error of the mean, or standard error. You can have standard error of any statistic. The standard error that we're going to see is standard error of the mean, or standard error of the sample mean. So, two different ways to write that, SEM or SE sub X bar. X bar means sample mean. Is used to represent uncertainty in an estimate of a sample mean and accounts for both sample size and variability, which is quantified by standard deviation. So it takes into account both how big the sample is and the standard deviation, how spread out the data are. The formula used to calculate standard error of the mean is shown here. It's the standard deviation, that's S, divided by the square root of the sample size. As standard error grows smaller, the likelihood that the sample mean is an accurate estimation of the population increases. All right, so before we get too much into the weeds as to what standard error is, we have the equation, let's calculate it. So standard deviation divided by square root of n. So let's go back to our data. I'm going to uncollapse it here. All right, standard error. I'm going to say equals, oh, let me make this bigger, sorry. I didn't mean to do that. All right, make this bigger so you can see it. Okay, so standard error equals, and if you remember the equation, it's standard deviation, which is this number right here. So I'm going to click up here, divided by the square root of n. So there's no square root symbol, but you can type in just square root, SQRT, of this value. And then I'm going to copy that to the right. Square root of the sample size. So 44 in this case, but don't type in 44, select that box. I'll do that again for people. So I took, it's this, so you go equals this, standard deviation, divided by the square root, SQRT, parenthesis, and then select the box directly above the sample size. And copy that over. Make sense? Next, we need 2 times that. You'll see why in a second. So again, just equal 2, and then the little star times this. I'll give you double that. You can copy that over. And I'm going to go back to the document. So we have a standard error of 3.3. All right, so use the equation to calculate standard error of the mean for both groups. Show your work. Now I'm going to type in this. So I just copied it over. And to get this, you'll type in the values that you actually got. So for the water group, it was standard deviation 40.95 divided by square root of, oh, I'm sorry, I took the mean, 11.14. Sorry. Divided by square root of 44. All right, I thought. And for the soap group, standard error equals, it was 4.18. Divided by square root of 42. So that's the work, and then I have the calculations right here, or the answers right here. All right, your homework is going to be to finish this. I'm going to make a video